and VLSI design. He heads the microprocessor development program and education and awareness program at IIT Madras, which is funded by the Ministry of Electronics and Information Technology. Also, he is the member of National Security Advisory Board. He was the chairman of Artificial Intelligence Task Force constituted by the Ministry of Commerce and Industry. He has over 150 publications in international journals and conferences and guided many research scholars for their PhD and research program. So far, he has received DRDO Academic Excellence Award, Indian Electronics and Semiconductor Association Techno Visionary Award, Abdul Kalam Technology Innovation National Fellowship, ACCS Lifetime Achievement Award, IBM Faculty Award, and Vasvik Industrial Research Award. So that was the intro of our expert speaker, who will be speaking on the topic out of the box thinking for problem solving. Before starting the session, I would like to call Mr. Deepan Sahu, Assistant Innovation Director, to add his valuable inputs to our participants join with us as IIC presidents, conveners, faculty members, students, and innovation ambassadors. Over to you, sir.
Thank you, Udyan. And I will welcome Professor B. Kamakoti, sir, Director of IIT Madras, for accepting our invitation and ready to share his knowledge and expertise and thought process on this very specialized topic, that is out of box thinking for problem solving using the science and the mathematics and other tools. And really, this session is going to be very useful for all this institute fraternity, educational institute fraternity, be it faculty, students, staff, or entrepreneurs, innovators. So all these members are now watching us, and we have more than 4,000 IIC institutions. Those have established these institutions, innovation councils, innovation ambassadors, faculty members. So I think this is a great opportunity for everybody. And before we jump into the session, and I will request Professor B. Kamakoti to address the session or take the session, I want to highlight a few things, which is very, very important for each and every individuals. And also it will help us to understand the whole concept in a better way. So as we say, we are the human beings, we are the best creation of the nature, and also we are blessed with very good special qualities like thinking, acting, doing, and also enduring from the difficult situations. And this is the quality through which we are already proved that we have all these innovation and entrepreneurship qualities, because we are surviving for a million years and we're evolving and we're advancing as we progress. But still, among this, there are lots of differentiations up there. So we have the basic qualities of the being an innovator entrepreneur, but we have to refine it, we have to identify it to further acquire certain skill set, and we have to see that how we will be better than our others, and we will solve the problems in a better and effective way. So problem is inevitable. When there is when we have to progress, when we have to make advance, then in the process of advancement, challenges comes in. And when there is a challenge, definitely there is a problem. And when there is a problem, then definitely there is a solution, because nature has already created certain solutions and it is there, and it is up to you and up to us how we are going to identify that solution. Either we have to discover that solution that is there in the nature, or we have to invent a new solution, or we have to acquire certain skill set to address that solution. So through many ways we can do it, and everything is science and use of system and methodology to develop the solutions for the problems. So today's session is going to address this connection between the problem and with the solution, and how we will match, how we will establish a good bridge between these two, so that we can say that we are an innovator and our approach is innovative way, and we are adopting a path of entrepreneurship. So connecting all these dots is going to be addressed in today's session. Without taking much time, I will request Professor B. Kamakoti, Director of IIT Madras, to take the session and enlighten us with the tools, theories, approaches, and also how we can implement in our daily life, so that we will that the path of innovator and entrepreneur that we are going to choose will become easy. So over to Professor B. Kamakoti, sir.
Thank you very much for this wonderful opportunity to address all of you. Um, Before I start the presentation, I want to give a very small introduction. We have been working on this particular issue, which is motivated by this very interesting observation by Bertrand Russell. If a reasonable person actually lives according to the society, an unreasonable person wants a society to live according to him. So if you want any change in the society, it is because of unreasonable people. So one thing that we need to keep in mind, that if we actually think the way the world is thinking, the chance that we will hit with something very novel and something different, something disruptive is going to be very less. So we have to cultivate within ourselves a way to think differently. Then only there will be a change in the society, and our different thinking, if it is going to lead to a solution that is more effective and affordable for many of the social societal problems, I think that is where we make an impact. If you are looking at a successful entrepreneurship, at a successful entrepreneur career, the most important thing that comes here is that you need to be in a position to think differently. You need to cultivate the way of thinking differently as early as possible. And early is something, it's just a number. So it can be even 80 years young. You can start that. But then your mind has to be cultivated to think differently. And that is where we are introducing a course, a 4-level course. There'll be 4 levels in this course called Out of the Box Thinking. I will present certain ideas about which came into our mind, certain introspection that we did before arriving at this course, and what would be that course, etc. As a part of this 40-minute lecture. And then we will open up for some questions. And I will also be providing the link. We are starting this course, which is free for all. Registration is free for all on July 13th. So I'll also provide you the link for this course. So this is what I'm planning to do in the next 40 minutes. I'll just open up the slides. First, the out-of-the-box thinking through mathematics. It is an initiative of IIT M. Pravartak Technologies Foundation with an objective to nurture young minds. IIT M. Pravartak is a Section 8 not-for-profit foundation of IIT Madras. Next. So I will start with the story, which is this apple knife stone theory. Right? So apple, there is an apple, there is a knife, and there is a stone. Please note that there is no connection between the apple and the stone. But to cut the apple properly, we need to sharpen the knife on the stone. If you don't sharpen the knife on the stone properly, you cannot cut that apple properly. Correct? So this is how problem solving is also. The apple is the problem that we need to solve. It can be a societal problem. The knife is our brain. And the stone is the foundation knowledge. If you don't sharpen your brain with the foundation knowledge, it will be very difficult for you to cut the apple, cut the problem or solve the problem precisely. And what the out-of-the-box thinking course will basically teach you is the foundation knowledge, in which if you actually sharpen your brain, you are expected to come with very, very different type of solution. And that is the objective of this entire exercise. So the main thing is that we need to train the brain to be creative, Creative essentially here means we have to think in an unconventional fashion. And we will give you examples as I proceed. I'll give you examples on what do you mean by thinking unconventionally. Now, ultimately, for an young student or even people who are in the first year of engineering or even trying to do research, there is something like when we look at mathematics today, if you ask a student, what is the concern with respect to mathematics? They say, I have to learn so many techniques, so many formulas, right? Now, what this type of an exercise to the brain will yield is it will shift the focus from this rote learning to what we call as the critical thinking or creativity and problem solving. And this is a must for next generation entrepreneurs who are going to or expected to solve the multiple social and economic challenges of our country. So we will be demonstrating in this lecture simple concepts, but which does not involve a formula or a technique or a process. And that is what we will be demonstrating here. And then we will also give you details of what the full-fledged course will be as a part of this lecture. Next. The basic idea today comes from our Thiruvalluvar, who wrote the Tirukkural. And one of Tirukkural is just this 1.5 sentence sayings, which are very important for leading the life. Thiruvalluvar is one of the most reputed, famous scholars of South India. So that the Kural goes like this: Ennenba ஏனை எழுத்தென்ப இவ்விரண்டும் கண்ணென்ப வாழும் உயிர்க்கு. What does it mean? The word, the alphabet, and the numbers are the most important lifeline for human being. So numbers are very, very important. And this is recognized. This is more than several thousand years old, and this has been recognized here. And many of our traditional games, right, which was played in ancient or even very recently, say 50 years before, the games involve mathematics. There is one game called Pallanguli that actually imbibe mathematical insights. And Pallanguli is in Tamil Nadu. The same game is played across different states. It's called Aliguli Mane in Karnataka, Vamana Kuntalu in Andhra Pradesh, Kuripara in Kerala. This involves a lot of strategies and lot of mathematics to play this game. And at the young age, when they start playing this game, they develop these new strategies and mathematical skills by itself. And this is something very important that even the ancient games have taught us. Next. We will come to some unconventional thinking. I will just put up some questions, pause for 20 seconds, and then give the answers because we are not on a live session. So let us say, what do you mean by this think differently? Let's take this sequence 1, 3, 5, 7, 9, 11, 13, 15, 17, 19. Guess what could be the next number in the sequence? $21 would be anyone's guess because it's an arithmetic progression. Well, it may be right, but any other thinking? For example, 31 is a correct answer. 31 is also a correct answer. That is a pattern. 1, 3, 5, 7, 9, 11, 13, 15, 17, 19, 21. The pattern is an arithmetic progression. But we could also have other patterns here. I just give, say, 10 seconds for you to understand why 31 could be correct. Okay. Let me count. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay. Hope somebody would have guessed it. But 31 is correct because if you look at the digits in 1, 3, 5, 7, 9, 11, 13, 15, 17, 19, they have all been formed using odd digits. Now, after 19, 31 is the next number that is formed only using odd numbers, right? Because 20 to 29 has 2 and 30 has 0. So 31 can also be a correct answer because that also falls into some pattern. 21 is correct because it is an arithmetic progression. 31 is correct because there's the next number which could be formed using odd digits, and all the previous numbers are formed using odd digits in that order. Right? So this is another way of thinking differently. Now let us take another example. Suppose I am given a circle and ask you to split it into two parts such that both the parts have equal area. So I'm given a circle. I want it to divide it into two parts so that both the parts have equal area. The simple solution would be divide this. The simple solution would be this, right? Cut it into two parts. But there can be another solution for this, right? This need not be the only solution. There can be another solution. If people have looked at Doordarshan and they would have seen the, the logo of Doordarshan. Yeah, this is another solution for the problem, right? And both have equal area. The white part of the first left-hand side is taken up by the black part of the right-hand side. So both have equal area. So this is another way of thinking differently. So if you are given a question, there is one answer which the world will quickly tell you. Anybody will tell you, but there can be another answer which is different. And this is what we mean by thinking differently. And this is something this course will address in a very comprehensive fashion. Now let us go into this who am I type of questions. For example, 1, 2, 3, 4 is a 4-digit number. 6666 is a 4-digit number made of repeated digits. Okay. So this is the question. A number is speaking once. I am a 4-digit number made of repeated digits from only one digit. So like 6666, 5555. I am closer to 2000 than 3000. Who am I? Right? I am closer to 2000. I am a 4-digit number made of repeated digits from only one digit, like 6666, and I am closer to 2000 than 3000. The question is, who am I? Right? The answer, one of the immediate answer we can get is 2222 because 2222 is closer to 2000 than 3000. If we take 3333, it is closer to 3000 than to 2000. But what I hope many of you, is there some other answer? Again, I'll count 10 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay. There is one more answer here. The answer is also 1111. Okay, which is also closer to 2000 than to 3000. So what happens is many people actually look at a number line. The moment we say 2000 to 3000, people, the mind now looks at a number line between 2000 and 3000 and fix 2222, which is a repeated 4-digit number, which is closer to 2000 than to 3000. Well, the number line is not stated in the question. We have to see beyond the number line and we see another 1111, which is closer to 2000 than to 3000. And this is something which is again, what happens is when you go through a learning process, there are certain concepts like number line, the left-hand limit, right-hand limit that are fixed in your mind, and your brain doesn't think about something beyond this line. And this is an example that we could state here. Right. Now let us go into, this is also something. So we have lot of who am I type of questions, who am I type of training that we could look at from this course on out of the box thinking. Now, lot of things can be taught by, by telling stories, and I'm going to tell you some story. kid is asked for, see, something like in your entire entire education process, many of you who you would have experienced yourself, or when you see some people who are married and their kids are in the first or second or third standard, you see the point where they struggle is division, right? And there are a lot of problems which involve division, right? Addition is the easiest, subtraction is slightly difficult, multiplication is a little more difficult, sometimes as complex as subtraction, but certainly division is very, very difficult. Of the four operations, the most difficult is division, but we can teach division in a very nice way. There are problems which you can solve without understanding that way of division, like you put 4 by 7, and especially when it comes to handling real numbers, 2.3, 4.4, that becomes much, much more complex here, and typically students make mistake here. So the easiest way to introduce division is by storytelling. So let us say Vinu is asked this particular question, is 4 by 17 or 4 by 25, which is big, right? Now let us try to answer this question without introducing the process of division. Like you put 4 is the 4 by 17. So put a point, put 40, then 17 twos are 34, so 0.2. Without doing that type of a calculation, how can we teach that 4 by 17 is bigger, 4 by 17 or 4 by 25, which is bigger, right? Now let us go and start looking at the story, right? Now this is a very simple story. So Pati means in Tamil, it's grandma, and Pongal is a dish, let us say, right? So 17 grandchildren visit the village of the grandma on day 1. And Vinu is one of them. Grandma makes these 4 pots of Pongal and distribute to 17 grandchildren on day 1. Let's say each pot holds 1 kg. So what each will get? They'll get 4 by 17. Right? This is easy as a concept. Right? So Vinu is one of them. So Vinu will also get 4 by 17 as his part. So next day, what happened? 8 more grandchildren arrive on day 2. But the grandma makes the same amount of Pongal and distributes to these 25 children on day. So each will get now 4 by 25. Now, how much did Vinu get? And which day did Vinu get more? Obviously, it's very easy for Vinu to say, okay, I got more yesterday because it was divided among 17 people. Today, it is divided among 25 people. So by this, we can easily go and say 4 by 17 is greater than 4 by 25 because we know you got more on the first day, which was 4 by 17, than on the second day, which was 4 by 25. So it's a very, very simple, easy way by which we can introduce these fractions and the comparison between fractions by this simple story. Once you get into the story, so now your brain will start thinking differently because when you give 4 by 17, it doesn't go to the table and start dividing 4 by 17, right? It now starts thinking with this grandma and Pongal type of story. Now, how can this develop a little more? We'll go into a little more complex question, right? Is 13 by 17 greater than 21 by 25? Now, a brain which is tutored as this grandma Pongal story is expected to start thinking about this 13 by 17 greater than 21 by 25, not as a division problem, but also something more, something different than that. And let us see how the brain can potentially think. There are other ways of thinking, but one solution is what I will suggest here. Now, let us say Sujata has arranged a party of 17 people. She got a pizza and divided into 17 parts. Okay. Only 13 turned out. Now, how much is left over? This is a question. So, Sujata arranged a party for 17 people. She got a pizza and assuming 17 will come, she cut it into 17 equal parts. Only 13 turned out. How much is left over? Right? the amount that is left over is 4 by 17 because 13 turned up. They will have eaten that part. So each would have got 1 by 17. So 4 people did not turn up. So they got 4 by 17. Now let us take this next question. Kriti arranged a party of 25 people. He got the same pizza as what Sujata has got and again divided into 25 parts because 25 people he has invited. And only 21 turned out. Right? So how much is left over? 4 by 25 is left over. So in case of Sujata, 4 by 17 is left over. And in case of Kriti, 4 by 25 is left over. So who has more, which had more leftovers? Obviously, 4 by 17 is greater than 4 by 25 that we have already seen. So Sujata had more leftover than Kriti. So from this, what you see? So Sujata's team has 4 by 17 leftover, which is greater than what Kriti's team had, which is 4 by 25 leftover. That means 13 by 17 is less than 21 by 25. So this is a very clear thing. We have not used division. We have not used the calculator. We have not used anything. But just by using this concept, we are able to now go ahead and say, solve these problems in a very, very comprehensive manner. So this is certainly something different from what we conventionally do in a mathematics course. Now let us go into this very interesting question. I'll give you only 2 seconds. Which one is smaller? 17 by 32, 19 by 36, 13 by 28, 21 by 40. Which one is smaller? 1, 2, done. Okay. It is 13 by 28. Because that is the only number that is less than half. Right? So just take 17 by 32. 16 is the half point, right? So 17 by 32 is greater than half. 18 is the half point. 18 by 36 is greater. 19 by 36 is greater than half. 20 is the cusp point. 21 by 42 is greater than half. But 13 by 28, 14 is the cusp. So 13 by 28 is less than half. So normally when you get such type of questions, right, the normal way of brain thinks is just try to divide and do something. But now having one anchor point, so we really need not know what these numbers mean. But if you have an anchor point like half, right, and compare everything with that half, we can very quickly now segregate it into parts and answer these type of questions. So this is another way of thinking, right? So I am now looking at half, which is not part of this sequence at all. But using that half, I am able to segregate the sequence into smaller and larger component and take the smallest one out, right? So these are some examples, very, very tip of the iceberg of what an out of the box thinking type of course will teach you. Now let us look at one more here. With this, I will, wind up to it. See, suppose this is a very interesting thing. Like so, we can. So I am giving you some threes, right? I'm giving you 4 threes, 4 numeral symbols of threes. And you are expected to use any of the arithmetic operation you know, right? But you want to have the value 27. So I'm giving 4 threes. You can put it in whatever order, and you can use any of the arithmetic operation. But the answer you should get of that expression evaluation, you should get 27. So the way I can use these 4 threes is 33 minus 3 minus 3 equal to 27. Right? So if I'm given 4 threes and any arithmetic operation, I can get 27 by this method. 33 minus 3 minus 3. So I'm using 4 threes here, 2 threes in 33 and 1 3 each in minus 3 and minus 3. And I'm using the arithmetic operation minus. Right? Now suppose I'm given 3 threes. Right? Quite easy for you to do. I can now say 3 into 3 into 3. So I'm using that 3 times here, and I'm using the operation into to get 27. Suppose I'm giving 2 threes. Again, it's very easy for you to. 3 power 3, right? 3 power 3. Then there is only 2 2 3s, and I'm using the operation power. So 3 power 3 is 27. Here comes the atom bomb. Using only 1 3, can you get 27? Okay. Right? So I'll not give the answer here. This will be dealt in level 3 of our out of the box thinking course. There is a particular topic called number builder, and in this we will teach you this how to get 27 using just 1 3, but any of the arithmetic functions. Okay, so this is how out of the box thinking as a course has been developed. You can, if you are interested in knowing that more about these things, you can register for the course. I will now give you some details about the course, right? So where does this mathematics actually play a very important role? So some of the very interesting facts. Do you know that the New Zealand and Australian Olympics teams brought along mathematicians as part of their team in 2016 Rio Olympics, right? Because they really want to study what is happening and give a lot more predictions there. And various fields need the logic that leads to the final numbers or calculations, right? So finally, the way we can make our brain think differently, the easiest way of training the brain is by using mathematics. And what we will have as a part of this course, right? We will have, we can look at a jumping frog. There is some very nice formulations that can come by observing how a frog jumps, or how a train goes from one station to another station and back, using sticks and bubbles, tessellations, sea travel, security code, etc. All has a connection with mathematics. And there are many things in this list which you will learn here. And all these things have brought together the development of this course called Out of the Box Thinking Through Mathematics. And this course, our objective is to keep it nice. Nice means new, inspiring challenges and engaging. That's how we have coined this word, and it should be nice to all. So this is for whom are we going to do this course? There are 4 levels. Level 1 is school class 5 and above. Above means it can go up to any researchers, professionals, retired people who have some time, who want to do something new. So there is no age limit. But class 5, some basic operations they may require to know mathematics, but then after that it starts. Level 2 is for school class 7 and above. Level 3 is for school class 9 and above, and level 4 is for school class 11 and above. And the total duration of these levels would be just 100 hours put together. So a student who is at class 5 need to spend 100 hours in 7 years till he comes to +1 or +2. I think total 100 hours in 7 years to do all these courses. And of course, there will be some assignments. And the above 4 are independent levels, and they don't have any upper age limit. So from school children to professionals to researchers, anybody can take this and benefit. And these courses are online, so you can do at your own pace. And this is about this course. Now, what do you see at level 1? You'll see a lot of puzzle maths. There's something called cow grass theory. Something, follow the sequence, and many things there. So there are many topics, but some sample topics we have put there. Level 2 would be frog jumping theory, cows and bulls, story math. I gave one example about story math, how to tell a story and solve some problem. That's only a small one, but you can see many things there. And in level 3, number builder. I gave you one example of a number builder problem, but there can be many things. There are many things here. Where is my friend X, right? It is about solving equations, and that is you do left and right across anybody involved in mathematics, till research, till teaching, you do this X. Modulo arithmetic. That's very important. A jolly ride with modulo. Level 4, we have things like Graphman, chasing the ratio, coloring math, so many things. Okay, so these are some few topics, but more details are there on the website. Next. So the structure of these courses, the courses are free online with recorded lecture. The level 1 and 2 will have 10 weeks, 13 topics for each level. So totally 26 topics we will do. And about 20 hours of recorded lecture for each level. So every week you will have 2 hours of lecture, and you can do this course and then you can write the exam. Levels 3 and 4, 10 weeks, 20 topics for each level, and about 30 hours of recorded lecture for each level. And there will be periodic assignments, evaluation, assessment, and answers will be provided. Next. So the benefits of this course is the unique course presents multiple approaches to problem solving, debugging the myth that problem solving is for the elite. It introduces new techniques in an easy to understand fashion, prepare the users to face real life projects with confidence and ease. And these different innovative thinking are needed to make the children of India to become entrepreneurs, to bring up new, simpler solutions for our socio-economic problems, and a very good aid to cracking many international Olympiad and competitive exams too. Right? So these are all the overall benefits that we envisage through this course. So the levels 1 and 2 commences from July 13th, 2022, and it will go in parallel. Level 3 and 4 commences from January 2023. It will go in parallel. The same will be repeated every academic year. So every July 2024, we have 1 and 2, and examinations will be somewhere in December and May during the vacations. There'll be a proctored examination, which you go and write in a center. If you want a certificate for this, graded certificate for that. So this will happen regularly. So you can take the course now and write your exam anytime. So register, do the course. Registration, lectures, if you don't want to take the examination, everything is free. For the examination, there will be a nominal examination fee. So courses are free online. Final exam carries a nominal fee for opted candidates. This is for basically running the exam, just to cover the examination fees. And the final exam will be a proctored one conducted at centers in select cities across India. And there'll be a grade certificate based on evaluation of final exam, will be issued by IITM Pravartak Technologies Foundation. 85% and above, you get grade A, 70% to 85, you get grade B, 55 to 70, you get grade C, and 40 to less than 55, you get grade D. So this is how the examination would be. So this is the registration link, pravartak.org.in, out-off-box-thinking.html. Okay, just note it down, and all interested people can register for this. So this is what I have now, and I now open up for questions. So let us all work together to create towards a creative India while we keep enjoying mathematics. Thank you very much for this opportunity.
Thank you very much, sir, for such a great session. So I hope with your session, each of our participants found it very useful and will take the benefit out of it. So, sirs, we have only one question over here. Yes. Like question from Bala Gopi. Whenever a problem is given with different solution, average mindset person immediately rejects. How to convince them and move forward?
Okay. So one point is examination, where you need to convince the examiner. The other point is basically that you need to solve the problem, and the solution is to convince yourself, right? So two aspects. Many times when you become an entrepreneur, you want to convince yourself of the solution, and that is where this becomes extremely useful. And when you go in for a normal thing, the second way of solution, say suppose you are writing an examination, a public examination, and you solve it in a different way, which will not be in the marking scheme, and somebody who doesn't understand the solution may mark you 0. It's a very valid concern. But what can happen is your quick solution can give you the answer, but you can then work out in the conventional way and confirm whether both these agrees. So that way, this can be a very quick way of checking, a different way of checking whether your answer is correct, right? So So both for people who are writing an examination, when given a problem, they think in an unconventional way, they get the solution, but they then do the same conventional way and getting a solution, they can check. So this is one, because of the real fear or real concern that the marking scheme may not have this solution, and the person who is evaluating may reject this answer. But for this is one part. For the other part, where you are an entrepreneur, you need not convince another fellow that this is the solution first, because you are solving the problem for yourself. This will be a very quick aid to solve the problem. So this is the way I view this entire exercise.
So one more question just came now from Dr. Manoj Kumar. How to make the student to think out of the box?
Just giving these problems. So for example, I have circulated 5 problems, multiple choice questions to Udian. I think you will be circulating it to all the participants. So try and solve those problems, give it to the students. The moment they start looking at these problems automatically, and some guidance through this lecture, you can make them enroll for the out of the box thinking course, which will teach them some techniques of how do you show some pathways on how do you think out of the box, and gives a lot more of these questions. I think automatically this process will start. They'll start thinking out of the box. And we have experimented this for more than 12 years with many children, and they have come out very nicely, and we're very, very successful in Olympiads and other. And they have also, many of them have become very good entrepreneurs too. So this is the way we go about on this.
So those were the only questions were asked.
Okay.
So I hope all our participants must have enjoyed the session and watched it enthusiastically. So they were really good examples taken by you, and I hope these participants will implement in their daily routine that how to think differently or how to solve a problem in a different way by not picking up easy answers. So thank you once again, sir, for giving us your precious time and delivering us such a great session. Thank you so much. Thank you.
Thank you very much.